Welcome friends, I am Tanmoy. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss a name reaction, that is Pinner reaction of nitrile. Means actually reaction of nitrile. This is a Pinner reaction. This is a conversion of nitrile into ortho-ester, amidine, thio-ester, ester, etc. So this is not generally that much famous name reaction, but its application is very good. So I believe you should study this, because nowadays it is very difficult to predict the question source from where this will come. So definitely read all those important name reaction, along with that read these also, because if you read this, if the name reaction, the main reaction associated with the name reaction is given to you, and if you are familiar, it will be very easier to perform the attempt the question as well as save the time, because the question is easier. So this is, so what we are going to learn today, we are going to learn almost the all important thing for this reaction, like basic concept, why it serves as scope, Pinner salt mechanism, why acid, why not base, because this is needed, and choice of reagent, condition, and role of each reagent. Okay, so a lot to be discussed. Let's start. So as you can see that this reaction is actually, you may consider that addition reaction on nitrile. Exactly this is not true, but you may think like that. Why I am saying, if we consider nitrile RCl, you see there is a triple bond, fine, and there is a lone pair. So addition means whatever, some part will add here, some part will add here. But what happens that actually it is addition, sometimes hydrolysis also occurs during the reaction. So that is another uniqueness of this process. So what happens? So see, acid is given. So what is expected? That it will react, it will protonate this, and if it gives electron to the proton, then what will be that this positive charge will come on the nitrogen. And if this nitrogen is positively charged, what is expected? That the electron deficiency of this carbon will arise. How? Because it will have another canonical form, that is R C double bond NH carbon plus. And generally we know that the positive charge prefers to sit on the less electronegative atom. So here octet filled, here we can say octet filled, but here this is 6 electron, but the positive charge is on more electronegative atom like carbon. So both have significant contribution and both are responsible for the reaction. So what this indicates, that since electrodeficient or electrophile, this is actually a electrophile. Okay, so electron deficient. So what happens? Any nucleophile is expected to attack. Means nucleophile any will attack here and it will open up. See? And for this purpose, if you use alcohol, what is expected? So what will be the part of nucleophile reaction? R C double bond N H, and this is nucleophile. Okay, so if it is nucleophile H, this thing. So instead of this, if we take alcohol, I am first discussing the simplest part, after that we will go slowly to the difficult part. So if we take alcohol, then this oxygen can act as nucleophile. So it will attack and it will open up, and what it will produce? Initially it will produce this formal positive charge on this. Let's take R prime. So this, now what will happen? That this proton will be eliminated, and where proton will be abstracted? Simply you can see that this medium is acidic. So you can't expect that, this medium is acidic. So first who can abstract? This nitrogen can abstract, or another molecule of alcohol can abstract. So what will be the consequence? So minus H plus, another thing next will be plus H plus also. Why I am telling? So R C this NH, fine, and here OR prime, fine. See, in acidic medium, nitrogen will not prefer to remain as free nitrogen because it will be protonated. So this and this moiety, this is named as Pinner salt. Why I am giving emphasis on this? Because in every case, this is the intermediate. Okay, from this intermediate, other thing will happen. So for this process, what is needed? For this process, at least one equivalent of alcohol is essential for the conversion of this nitrile to the corresponding Pinner salt. Okay, and Pinner salt is the precursor for our step. Fine. So now, as you can see in the second step, many reagents are used. For example, excess ammonia, alcohol, water, H2S, different variety of product produces. For example, if you use ammonia, it produces the amidine. Okay, if you use alcohol, excess alcohol, it produces ortho-ester. If you use the water, it produces ester. If you use H2S, it produces thioester. Let's learn this step by step. Okay. So if you use ammonia, what is going to happen? Ammonia in excess. Okay. If ammonia is excess, what it can do? Since C, this is a carbonyl attached to a nitrogen having positive charge, so expected that another canonical form. So what is expected? These are OR prime, carbon, NH2, and positive charge is on carbon. So what is expected? This center will act as an electrophile, and secondly, this positive charge is also resonance stabilized by this. So it is not that much unstable. Okay. So I am not going that much deeper on every canonical form. So fine. Now what is expected? That since ammonia is a good nucleophile, so it can attack here and it can open up. So what will be the product? R OR prime. This is NH2. Sorry, this is NH3 plus, and this is NH2. See, now the medium is acidic. So what is expected? That this can be protonated since the medium is acidic. So in acidic medium, in second step, first ammonia attack, second step H3O plus. Sorry, we should, okay, I'll come. Not H3O plus, H plus. So what is expected? That H plus will be added formal positive charge. So that time this ammonia will push and it will come out. So what will be the result? Resulting product will be R double bond NH2 plus, and it will remove another proton because dye positive is not a very favorable thing. Okay, and why this? Why I didn't written that NH3 plus and NH2? Because this molecule have an equivalent canonical form, means that this lone pair could be donated. If it donated here, so it opens up. So what is the product? R, this is NH2, this is NH2 plus. See, this phenomena is called equivalent canonical form. And when such type of opportunity exists, what happens? That contribution of both canonical form is almost same. Now let's come to the just amidine part you have observed. Now let's come to the role of acid. So what acid is used? Generally anhydrous. I should write here anhydrous. Anhydrous HCl is used in organic solvent. Organic solvents like benzene, toluene, nitrobenzene, chloroform, etc. So means the anhydrous HCl is taken. Okay. Second, since I am telling anhydrous HCl, then it is instantly the question will ask that if HCl is anhydrous, then expected all the solvents are anhydrous. Yes, this actually okay. Solvents are anhydrous, HCl is anhydrous. Then the instant question will come. Since I have used alcohol, then alcohol should be anhydrous. Yes, alcohol is also should be anhydrous. And keep it in mind, anhydrous alcohol preparation is very difficult because alcohol is very hygroscopic. Pure alcohol is very hygroscopic. Okay, so anhydrous alcohol in this case, ethanol, butanol, propanol, etc. could be used as a reagent. Fine. So for peanut salt preparation, one equivalent. But if we want further, then we need excess. And keep it in mind, every case anhydrous thing is essential. Why, I shall explain later on. So acid part we have discussed. Okay. Then so similarly, now since it is prepared this peanut salt, now we can think that why not let's react this with alcohol excess, means this is ammonia excess, this is alcohol excess. By the way, you may think one question, why these attacks? Because after this reaction, what is happening? In this step, alcohol is produced, and this is also cationic. See right now. Then why alcohol is not attacking? So that is the factor of nucleophilicity. Nucleophilicity of alcohol is higher than nucleophilicity of amine is higher than alcohol. Consequently, what happens? Alcohol can attack here and open up this. Okay, but ammonia could do. In this context, I want to mention I have already uploaded a video about nucleophilicity. So please go through that. It will be helpful for you. Fine. So excess ROH. So what happens? These ROH attacks. So where it will attack? Similar process. So it will attack here and it will open up. So this is R. This is OR prime. Let's take excess means the same alcohol. So this is NH2, this is OR and H having a positive charge. So next step, what is expected? That this amine, among these all, you can see these nitrogens are more basic. So first part, this proton will be abstracted by some other molecule, means in the reaction medium or excess alcohol, etc. And the acid is that H plus will be absorbed by this. So as short we can say that this H plus will be eliminated from here, or H plus will be added from here. It is not essential that the process should be intramolecular, but exchange will occur. So what is R, OR? This is O, this is OR. Fine. And here this is NH3 plus. Okay. Since it is NH3 plus, acidic medium, so this can, one of the lone pair can push and this NH3 can eliminate. You will feel little awkward. I shall explain. This is R prime, this is O, R prime having a positive charge. Plus this is ammonia. What will happen? The reaction medium is acidic. So this instant released ammonia will instantly react with H plus to prepare the ammonium plus, and if we take anhydrous HCl, so it will be ammonium chloride. Generally HCl is taken. Okay. So this is, and it will be precipitated out because the medium, you can see that's an organic medium. For example, that as I told, benzene, toluene, nitrobenzene, etc. So this is actually an organic medium. So expected it will be precipitated out. Okay. So then this phenomena discussed why it will go, because in equilibrium maybe probability of this reaction is less in equilibrium, but if some amount of this happens also, then the overall equilibrium will shift towards right side. Okay. And another thing, see, in this way the ammonia is getting out of the reaction mixture, precipitating out. So equilibrium will be shifted. Fine. Okay. So then what is expected to happen? This is positive. This, so it has another canonical form. What is that? This ROR, carbon having the positive charge, and this is the OR. So what does it mean? That this center is electron deficient. So what is expected to happen? In next time, excess another this ROH will attack, because this is not that much stable. Alcohol is in excess, so it will attack. And what will be produced? It will produce R, OR. This is OHR prime. Another thing, OR prime. It opens up. Now see, it will have a formal positive charge. So if this proton is eliminated, so what will be? The product will be ortho-ester. What is mean, or what do you mean ortho-ester by ortho-ester? Ortho-ester means, you can say ketal or acetal, not say ketal, acetal of carboxylic ester. I shall explain. So what it will produce? Ultimately, by the elimination of H plus, it will produce R. This is OR prime. This is OR prime. This is OR prime. In short, R, C, OR prime twice. Why? So if we have a ester of, if we have a primary ester, that is CO, OR prime, and we are reacting with two molecules of R prime OH, and one molecule of water eliminates. Similarly, like acetone plus two molecule of ethanol forms acetal, and one molecule of water goes out. Similar thing. Okay, so similar thing. Minus water. So this you can consider as the ortho. This is the ortho-ester. So previously we have discussed about amidines. Now we have discussed ortho-ester. Now the interesting part started. Okay. So till now what we have learned? Till now what we have learned, that whatever nucleophile present in the medium, whether it is alcohol or whether it is excess ammonia, ultimately product will be governed by that. But keep it in mind, if I am saying that ammonia, then don't think that we don't need to use alcohol. We need to use alcohol. It is essential to use alcohol. Okay, otherwise this penal salt formation will not happen. So this point you must keep in mind. Fine. Okay. So now let's come about now how to prepare ester. So as I told, if you react this with water, okay, water, what is expected to happen? And water we should represent, I always suggest that water we should represent as HOH. This is the delta plus, this is the delta minus. So similarly, water will attack here, it will open. So ultimately what is the product? R, OR prime. This is NH2 and this is OHH. Formal positive charge on oxygen. So next step, it is expected that this proton will be eliminated from this, and in the reaction medium, that ammonia actually more basic than oxygen, so this will be NH3 plus. Fine. And this oxygen has two lone pair, it will push and it will leave. So what will be the product? R, see, this is OH plus, this is OR prime plus ammonia, and the ammonia will same way react with H plus and go out from the reaction medium. This, and if it eliminates one H plus, so it is ester. Okay, so now the question comes, why anhydrous? Okay, so if you don't use anhydrous condition, there will be water in the reaction medium, and if water is present in the reaction medium, it will either result in ester, or in the first amidine case, instead of amidine, it will prepare amide, means RCONH2. Understood? So that is the importance why we should use anhydrous condition. Otherwise, this will result in amidine formation. Okay. So now the question, how thioester will be produced? So simple. Instead of water, if you take H2S, nothing, sulfur is H2S and water and H2S is different, is that sulfur. So if instead of here, if you provide the sulfur, means RSOH, this is thioester. Okay, so in this way this product are produced. So till now what point we have discussed? We have discussed about the basic concept. Wide substrate scope, because one pinner salt, this is capable to provide this many substrate. Okay, this pinner salt we have discussed. We have discussed mechanism. We haven't discussed acid choice of reaction condition. Okay, one part I missed. That is the choice of reaction condition. Generally, it is chose that reaction should be carried out around 0 degree centigrade. Why? Because you can see that all the reagents are sufficiently reactive to carry out this reaction. So 0 degree centigrade temperature or room temperature is enough for this process. Fine. Choice of condition and role of each reagent we have discussed. Now condition is why acid. Why acid, and along with that condition, is it a general rule that we have to use acid? Can we avoid this? Can we use base? Question answer is yes, we can change the condition from acidic, even acidic or basic, or even without any base or acidic. Actually, why we are using acid? So that is the question. To answer this question, we have to go back to the basic concept once again. What the basic concept? These are CN. Okay, this is as a basic site. So what it will do? In presence of acid, it will form RCNH plus. Now this is electrophilic. This is delta plus. This is delta minus. This is also electrophilic, or more precisely, if we say this is more electrophilic compared to the previous one. Fine. Okay. Is it true that always it will be protonated? No. If these are constrained electron withdrawing group, okay, then what is happened? This is not the low availability of electron density of the nitrogen is low, so less electron density. How you may think that this is not involved in resonance? How this should have a less electron density on this nitrogen? I believe this is not involved in resonance, but if they are in conjugation, for example, if you take this nitro substituted, means this electron withdrawing group. Okay, so that time if you consider this aromatic and nitride with electron withdrawing group, so what is expected that this nitrogen will have relatively less electron density. Why? Because actually sometimes we consider electron as a particle ball, but majority of time it is better to consider electron as cloud. Okay, this is my personal opinion, is this makes the picture little easier. How? So if it is cloud, then this pi cloud is electron deficient, so electron density will be grabbed slowly this side, so electron availability of nitrogen will be less. So that time this protonation is actually donation of electron to the proton, so that will be less. Fine. So this step we clear. So it means that if our nitrile is electron rich, then it is expected that that no problem, protonation will increase the reactivity further, it will perform efficiently. But if it is not electron deficient, if not rich, then it is electron deficient. So electron deficient. And in organic chemistry, when some case, if it is not efficient in a particular situation or circumstance, if it is less efficient, in some other circumstances is more efficient, that is actually happens. What do I mean? So if it is electron deficient, then electron rich means nucleophile. For example, let's take alkoxide. This alkoxide can attack efficiently. So this will attack. What will be the consequence? Let's consider this thing as a R again. So R, C double bond N minus and RO. By the way, I forget to mention, this acid is needed catalytic amount. So I forget to give you the explanation, but it is needed catalytic amount because in first step it is consumed, then ROH attack, again ROH releases one proton in order to be, this oxygen cannot carry a positive charge, it's not stable, so oxygen releases proton. So in this way the proton number balance and acid is actually acting as a catalyst. Catalytic amount of acid is efficient. So here alkoxide, so what we have, for example, we have taken sodium plus counter anion. So this means Na plus. So what is expected that this N minus again will react, and not write it. So this again will react with another molecule of R prime OH. It will abstract the proton, it will open. So what will be the product? R C O R double bond NH. This is actually Pinard salt means the cationic form, but it is not exactly Pinard salt but that derivative. Okay, so if right now if you use ammonia, it will attack because it is an alkaline medium. This ammonia may attack or it may be converted into NH2 minus in presence of base. Okay, in presence of base it may be converted to this NH2 minus, which can attack. Which can, instead of this can attack. So what will be the product? R C O. This is NH. So if it is attacked, it will open up. So we should write that. This is NH minus. This is NH2. This is OR. What? It will again push. It will leave. So what will be the product? R double bond NH double bond NH2. Amidines in alkaline medium remains in this form. How to isolate? It is needed to be isolated in presence of slight amount of acid. Then as a salt it precipitates out. Then it converted into this. The same. How ester produced instead of ammonia, this second part. Okay, let me draw it again. This part enough. So how if instead of that alkoxide which is regenerated here, again alkoxide is regenerated, RO minus, R prime O minus, this is better to write. Okay, so this R prime, sorry I made mistake for last time, so don't get confused with R and R prime. This is R prime O minus, it will attack, so it will open definitely as it is. So what it will result? R C NH minus OR prime and again OR prime. Okay, so what is that? This NH2 will again be converted to neutral by abstracting a proton from the solvent, means alcohol which is in excess amount. So it will push, it will come. So what it will result? R C OR plus double bond OR prime. Now here ammonia is produced. So what will be the fate? In alkaline medium, ammonia is not soluble, so it will go out as a gas, separate out from the reaction medium. Previously it was separating out as a solid, salt. Right now as a gas it will go out. So next time R prime O minus alkoxide. How? Because here alkoxide attacked, then N minus was formed. That N minus abstracted, means R prime OH2. It formed R prime O minus. So again O minus generated, regenerated. That will attack. Okay, now. So ultimately, what is the product? The product is R C OR prime OR prime OR prime. Fine. This is also the ortho-ester. So I guess you have understood how in alkaline medium similar thing will occur in case of water and H2S. Okay. Okay. And now one part is left for discussion. I have discussed about the acidic as well as alkaline. Now question, what about the neutral? In which case this neutral means neutral environment, not acidic, not basic environment will work. Actually it works, but there are limited examples. So I will give one example for this purpose. So you can think that RCN, our point of interest, if R is sufficiently, means R is sufficiently withdrawing but not conjugated. Okay, means R sufficiently electron deficient but not in conjugation. What do I mean? If conjugated, then this cloud, otherwise through sigma withdrawing will occur. Okay, so one of the example is trichloroacetonitrile. See, only sigma withdrawing operates because of this electronegative chloride. Okay, so this carbon is highly electron deficient. Highly electron deficient. So what is the consequence? That it can automatically get attacked by alcohol. Means if we think in this way, so this, what will be the product? CCl3 double bond NH minus OR prime H with plus, then this plus will, this proton will be removed and it will be this NH2. And medium is neutral, and we know in neutral medium this NH2 can act as a base. So what is expected? That from RO, if we have excess alcohol, keep it in mind similar phenomena, just I am giving only alcohol's example. So this will abstract this proton and it will generate the base again. So CCl3 double bond NH. No, I should not write NH2, it should be NH. Okay, so this is NH. Now it should be NH2 plus. I made mistake. NH2 plus, this is OR prime. Fine, so what is expected now? Again this it resulted into R prime O minus formation, and this R prime O minus, good nucleophile, will attack here, it will open. CCl3, sorry, this is NH2, this is OR prime, this is OR prime. So similarly, in reaction medium, now it will be converted NH3 plus, so they will push, it will eliminate. So CCl3 OR prime, this is having a positive charge. So from when it abstracted the proton, it generated again an RO minus, which will attack, and ultimately it will open up and so ultimately finally after elimination of proton, what it will result? It will result this and this. similar ortho-ester. Okay, so I am not explaining everything again. So this is the overall discussion of this spinner reaction. So what we have learned. So okay, before going to that, as a reminder, this C, you may be little shocked or surprised that CCl3 is it so much electron deficient. Let me give you an example in order to answer this confusion. For example, if you take acetaldehyde versus CCl3 this. Now if you discuss about the gem-diol formation percentage, generally we know that apart from formaldehyde, other aldehydes do not prefer to remain gem-diol as the energy of C double bond O is higher than the individual 2COH, and secondly here entropically it is unfavorable because another molecule of water means two molecules producing one molecule. Okay, so who remains in higher gem-diol conversion? This. Why? It is instantly in medium and it produces Cl. O minus, actually it is better to write OH. Here is also OH and this is an H. So in reality, what happens? It produces this gem-diol and it remains and it forms a hydrogen bond with this. Why this attack possible? Because with this minus I of this Cl. Okay, so this example gives a proof that this CCl3 minus is a very electron withdrawing group. Here in case of aldehyde it is showing, there in case of nitrile it is showing. And in this context I want to mention I have already made a video about the gem-diol which explains this all this factor elaborately, so it may be helpful. Please see that video, it will be helpful for you. So this is the end of the discussion. So what we have learned? We have learned a pinner reaction, which is an efficient technique for the preparation of amidine, ortho-ester, ester, thioester from corresponding this ammonia, alcohol, water or H2S respectively. Fine. We have learned about the mechanism, choice of reagent, even acid, basic, acidic, basic, neutral, and why should we choose a particular reagent and when, what is the condition. We have learned everything through this today's discussion. So if this video is helpful for you, please share this video with your friend such that many people could be benefited from my effort and I shall be very happy. So try hard, all the best, God bless you, see you in my next video.